Hello student friends, hope you are in best health. Today we are going to see very interesting video in which we learn cations, anions, their charges, and this learning process will help you to understand formation of various chemical compounds. While entire video is involving the various types of acids which make up anions, and it is very interesting to know how anions come from various type of acids. I hope you will make best of this video for enhancing and enriching your chemistry. Hello student friends, we will come to one of the interesting and the basic foundation topic associated with chemistry called as radicals. If you have very good understanding of these radicals, writing a chemical formula in inorganic chemistry will become very easy. In general, it makes our life easier in the entire chemistry. So the first task is there, how to remember acidic radicals and basic radicals. So that's the task that we are trying to do it in this session. Now what are acidic radicals and basic radicals? For your information, you know HCl is an acid. We know HCl is acid. We know sulfuric acid is also an acid. Right, and when they are dissolved in water, this acid HCl and H2SO4, when they are dissolved in water, they give you hydrogen ions and they give you another negative ions. Negative ions obtained from acids are called as acidic radicals. You can call acidic radicals even anions. They can be also called as anions. Remember that. Now NaOH, copper hydroxide are bases. Sodium hydroxide is a base, copper hydroxide is a base. When you dissolve them in a water, alright, this bases, typical bases, produce hydroxide ions. Along with hydroxide ions, they produce cations. Such cations are called as basic radicals. In short, acidic radicals are those which are obtained from acid and by dropping H+. Basic radicals are those which are obtained from bases by dropping or by loss of OH-. So acidic radicals are those which are obtained from acids by loss of H+, loss of H+, you can say. Basic radicals are those which are obtained from bases and by loss of OH-. The shorter version for you to know, acidic radicals are anions associated with acids and basic radicals are cations associated with base. For basic radicals, if you want to remember basic radicals, good knowledge of periodic table will help. So you all people should have basic knowledge of periodic table. So remember lithium, sodium, potassium, rubidium, cesium, which all belong to group 1, they will have a charge of +1. While beryllium, magnesium, calcium, strontium, barium will have a charge of +2. So remember, group 2 radicals will have +2 charge. Similarly, boron, aluminium, gallium, indium, thallium will have a charge of +3. While carbon can have a charge of +4, can have a charge of -4 also. Silicon also can have a charge of +4 as well as -4. Germanium, tin and lead can have +4 charge and even +2 charge. Germanium, tin and lead. From here onwards, most of the radicals have negative charge. So if you take nitrogen as an element, it will have a charge of -3 when it forms a compound. Phosphorus as an element, you will find it is a charge of -3 in its compound. Arsenic in its compounds will have a -3 charge when it forms an anion. Similarly, oxide, you are aware oxide, sulfide, selenite will have a charge of -2. Similarly, fluoride, chloride, bromide, iodide will have a charge of -1, while noble gases have 0 charge because they hardly form compounds. Periodic table will give you a very good understanding or realization of their charges. While transition metal, it's very difficult to understand from periodic table because they have number of valencies or variable valencies. Example, copper has a valency of +1, +2, while zinc has valency of +2. Zinc has a fixed valency, but other than zinc family, all other elements of transition elements have variable valency. So periodic table will help you to remember charges on basic radicals quickly. More about basic radicals is whenever a radical or a basic radical has a lower valency, its ending will be OUS. And when a basic radical has higher valency, ending is IC. So remember, letter O, this is the second letter of lower, and OUS first letter, they match. Higher ka second letter I matches with IC. So now we'll try to see the example. If you take tin, SN, which is a symbol, you know tin is a group 14 element. It shows a variable valency of +2 and +4. +2 is a lower valency. Because it is a lower valency, you end with the word OUS, and +2 charge is called as stannous. +4 is a higher valency, and for higher valency, you end with the word IC, and therefore called as stannic. Henceforth, tin with +2 should be remembered as stannous. Tin with +4 should be remembered as stannic. On the similar ground, lead, right, its Greek name plumbum has +2 charge also and +4 charge also. +2 is lower, so its name is plumbus, and +4 is higher, therefore its name is plumbic. So plumbus and plumbic, these are the names. So lead has two valencies, +2 and +4. Group 14 elements have tin, lead, and they have a valency of +2 and +4. Group 14 elements are carbon, silicon, germanium, tin, and lead, of which tin and lead have this popular charges. More transition metals have variable valency. Very lesser examples are there which has a fixed valency, like zinc has a fixed valency of +2. As a student, you are supposed to by heart. Copper has a variable valency of +1 and +2. +1 is called as cuprous, +2 is called as cupric. So remember, copper with +1, cuprous, copper with +2, cupric. Similarly, mercury has variable valency. +1, mercurous, +2, mercuric. Nickel, these are common valencies. Nickel has +2 charge. Silver, in most of the compounds you will find +1 charge. Cadmium is a common valency of +2. Iron has a variable valency, and lower valency is known as ferrous, higher valency is known as ferric. Similarly, gold has valency of +1 called as aurous. Gold with +3 is called as auric. Aurous and auric. So if you analyze again, stannous, stannic, plumbus, plumbic, plumbus plus 2, plumbic plus 4, stannous plus 2, stannic plus 4, cuprous plus 1, cupric plus 2, cuprous plus 1, cupric plus 2, mercurous plus 1, mercuric plus 2. Common valency of nickel cadmium plus 2, silver common valency plus 1. Iron has variable valency of plus 2 and plus 3, plus 2 called as ferrous, plus 3 called as ferric. Gold plus 1 is called as aurous, plus 3 is called as auric. That was about basic radicals. If you have this much information about basic radicals, it will give you that much amount of speed and faster learning abilities in organic chemistry. In inorganic chemistry. Acidic radicals. When you say acidic radicals, radicals obtained from acids called as anions. Now, when you come across as anions, anions can be of various types. Right? They can be elemental. That means made up of only one element. Elemental, made up of only one element. If you see Cl minus 1, it is called as chloride. Elemental end with the word IDE. Remember. So elemental anions end with the word IDE. Bromine, group 17, charge of minus 1, called as bromide. Oxygen has 2,6 as electronic configuration. Requires 2 electrons to complete its octane. Therefore, oxide. Sulfur 2,8,6. It also requires 2 electrons to complete its octane. It is also made up of only one element. Therefore, ending is IDE. But how you remember the charge on oxygen? You remember oxygen is group 16 element. That means it has 6 electrons in the outermost shell. That means it requires how many electrons to complete its octet? Yes, 2. So let's say 2 electrons. Therefore, we'll have a charge of minus 2. Why chlorine has a charge of minus 1? Chlorine is group 17 elements. Group 17 elements have how many valence electrons? 7. So they require how many electrons to complete their octet? Yes, minus 1. Therefore, they will have a charge of minus 1. So halogens, which are of group 17, will have a charge of minus 1. So chlorine, minus 1 chloride, bromine, minus 1 bromide, iodine, minus 1 iodide. Group 16 elements will have a charge of minus 2. Oxide, sulfide. Group 15 elements. Nitrogen and phosphorus. Nitrogen is 2, 5. It requires 3 electrons to complete its octet. Phosphorus 2, 5. It requires 3 electrons to complete its octet. So they are also made up of only one element. Because they are elemental anion, the ending is IDE, nitride for N minus 3 and phosphide for P minus 3. Carbon group 14 element 2, 4. Carbon can have plus 4 also, carbon can have minus 4 also. Imagine it forms ionic compound carbon, then will have minus 4 and can accept 4 electrons and will become carbide. Silicon 2, 8, 6, 4 can accept 4 electron and can become silicide. So remember chloride, bromide, oxide, sulfide, nitride, phosphide, carbide and silicide. These are all anions called as elemental anions. After knowing certain amount of basic radicals, it will be better that we do a small exercise where we can check whether you remember or not. So can you identify the charge on following basic radicals? So pause this video, go ahead and write down the charge. Hope you have written it, and you have written it correct. I feel. So what is the charge on magnesium? Yes, correct, +2, because it belongs to group 2. So it has 2 valence electrons and will lose 2 electrons and will have a charge of +2. What is the answer for second? It's +1, correct, because potassium belongs to group 1 element. Aluminium has what charge? Yes, correct, +3, because it belongs to group 13 element, has 3 valence electrons and therefore loses 3 valence electrons in formation of ionic compound and has a charge of +3. Zinc, +2, a transition element, very rare transition element which has a fixed valency of +2. Silver, yes, +1 is a common valency of silver, +1. Then there is one more exercise for you all people. Identify the name of basic radicals shown here. So shown here are the basic radicals. So write down the name of these basic radicals. So pause this video and write down the name of this basic radicals with proper suffix as us and ik, like mercurous, mercuric, cuprous, cupric, plumbous, plumbic, and so on. Pause this video and go ahead. Hope you have written it correct. So go, what is the answer for this? Correct, it's cupric. Answer for the next one. Correct, plumbous. Answer for the next one, mercuric, because +2 charge. For the next one, Aurus. Aurus, the name, Latin name for gold. For copper, cuprous, because copper has 2 valencies, +1, +2. Gold has +1, +3. Mercury has +1, +2. Plumbous has +2, +4. And copper has +1, +2. For tin, it is what? Correct, it is tannic, because correct tin has +2 and +4, and higher one is called as ick. Types of anions, second part. Acids are of two types, non-oxy acids and oxy acids. What are oxy acids? Oxy acids are like this. Sulfuric acid is oxy acid. Nitric acid is oxy acid containing oxygen. What is a non-oxy acid? Non-oxy acids are like this, which don't contain oxygen. Hydrochloric acid, hydrogen sulfide, hydrogen cyanide or hydrocyanic acids. These are acids which don't contain oxygen. Or acids not containing oxygen are called as non-oxy acids, and acids contain oxygen are called as oxy acids. Now we go ahead. Both the acids, whether it's a oxy acid or a non-oxy acids, have the ability of giving you H+. Now for you this is unusual, called as hydrozoic acid. Remember, it is not an ammonia. Ammonia and HN3, more often students get confused. Hydrozoic acid has 3 nitrogen, while ammonia has only 1 hydrozoic acid has 3 nitrogen, while ammonia has only 1 nitrogen. Now, coming to this discussion, all these acids, now after giving H+, they will give you acidic radicals. Naturally, these acidic radicals will be of without containing oxygen. All these acidic radicals end with the word IDE. So we have realized elemental anions elemental anions like this. Element which eventually become an anion, and anion obtained from non-oxy acid. Anion obtained from non-oxy acids, both of them end with the word IDE. So naturally, the first one is called as chloride. We saw this on the elemental anion side also. This is called as sulfide. Even this was seen on elemental anion side also. Chloride, sulfide. Then cyanide, coming from hydrocyanic acid. And this is called as azide, coming from hydrazoic acid. So, for you, unusual ones are cyanide and azide. If you want more, OH minus hydroxide, again ending with ide. But unusual, it has oxygen in it. But you can imagine HOH. If you take this, then after removal of, if you take this, after removal of H plus, whatever is left, that is called as hydroxide. Hydroxide is for us unusual case. It contains oxygen, but you can remember it as a separate unique case. Chloride, sulfide, cyanide, azide, hydroxide. Coming to the next one, if they are coming from oxy acids like sulfuric acid, nitric acid, sulfuric acid after giving 2H plus gives you SO4 2 minus. Why 2 minus? Because 2 plus charge is taken away by hydrogen. So 2 minus. 1H plus, hydrogen takes away 1 charge. So there will be minus 1 charge on this. Such anions end with the word, their suffix is ate and ite. So name of this is sulfate, name of this is nitrate. So the question is, which anions end with the word ate and ite? The answer is anion coming from oxy acids end with the word ate and ite, coming from oxy acids. And those who come from non-oxy acids end with the word ide, and those who come from element, they also end with the word ide. Now with this, we try to go further on. If you really want to remember many acidic radicals, then you should know large number of acids. Now, are you aware what is this acid called as? Yes, sulfuric acid. How to remember? And this is sulfurous acid. How to remember? If it has more oxygen, more, that means higher. So I see. If it has less oxygen, less means low oxygen, then OUS. You remember? Higher IC and lower OUS. You remember like that? So sulfuric acid, sulfurous acid. While this acid contains more oxygen than this one. So if it has contains more oxygen, nitric acid. While this contains lesser oxygen, so nitrous acid. So nitric acid and nitrous acid. Similarly, oxy acids of chlorine we like to learn. Now there is a different perspective. This has more number of oxygen. Therefore, ending is chloric acid. This has less number of oxygen. So, OUS acid, chlorous. But this has still less number of oxygen. If it has still less, you end it with the word OUS and you add the word hypo too. So, hypo means less, hypochlorous acid. Now we are left with the first one. In first one, you have more oxygen than expected. More than expected. Still more. I can say like this. Still more. So end with the word hyper. That means more. And ik. Ik is for more or higher. But higher se bhi higher इसीलिए hyper. Now for convenience in chemistry, high word was dropped in science or chemistry. So the name became perchloric acid. So what is the name of this first acid? It is perchloric acid. What's the name of the next acid? Yes, chloric acid. What's the name of the next acid? Third one. Chlorous acid. What's the name for the next one? Hypochlorous acid. So remember, it was believed in olden days 3 oxygen for a chlorine is quite a large. Therefore they wrote ic. But when they discovered acid with still more than 3 oxygen, 4, they call it as hyperic. And high was dropped from the name. High was dropped from the name, and therefore the name is perchloric acid. If it was less than 3, lesser oxygen, so they ended with the word OUS. And when they discovered an acid with still lesser number of oxygen, they use the word hypo and OUS. Here, high word was not dropped. It went with the name properly. Hypochlorous acid can be written as HClO or it can be written as HOCl. If you want, what is the correct way of writing? Correct way of writing is the first one. Now, this is one perspective of seeing it. There is another perspective also looking at it. What is another perspective? If you know oxidation state, then by oxidation state also you can learn it. In this case, first case, chlorine, central atom, if you use redox reaction logic, it has oxidation state of +7. While this chlorine has +5. In this case, chlorine is +3 and the last chlorine is +1. So this was imagined as high, while this was found to be still higher than expected. While this was imagined as low and this was still low. How to say still low? Say the word hypo and us. You want to say low and with the word OUS. You want to say high, ic. You want to still high, per and ic. So chlorine has 4 acids. HClO4 is called as perchloric acid. HClO3 is called as chloric acid. HClO2 is called as chlorous acid. HClO is called as hypochlorous acid. Now really, if you are quite interested in chemistry, go ahead, write down what you are able to see from the screen. Write down the structure and write down the name. You can pause this video and write down the structure and the name. Hope you have done it. Then more oxygen, you have realized we end with the word ic, and if there anion is there, anion coming out of such, then we end with the word ate. If it has less oxygen, then acid ends with the word OUS. Anion coming out of it will be called as ite. Are you able to see wherever this type of symbol is there? Remember the trick. So this symbol tells you that remember the trick. You are able to see a brain and a bulb. So brain, bulb. हम लोग का brain bulb जैसा है, कुछ कुछ जगह पे चमकता है, तो यहाँ चमकेगा. सल्फ्यूरिक एसिड, सल्फ्यूरिक एसिड राइट पानी राइट वाटर में डिसॉल्व करने के बाद 2 आयन्स दे सकते हैं, H+ और HSO4. आपको क्या लगता है HSO4 पे क्या चार्ज रहेगा? यस सही, -1, क्योंकि +1 इसके पास है. Because it is coming from ic acid, its name will be 8. An ion coming from ic acid is 8. Now it still contains 1 hydrogen, then such are called as bi. So we get the name as bisulfate. When is the word bi used? If an anion still contains replaceable hydrogen. So bisulfate. It is also called as hydrogen sulfate. But that's quite easy name to remember. Bisulfate is something unusual for us to remember. If you take bisulfate with a -1 charge, If it loses H plus further in water, then what do you expect? Will there be a charge on SO4? Correct, -2, because the charge here and the charge here should match. So it should be -2. And such an anion obtained from an anic acid ends with the word ate. So this ion is called as sulfate. So remember, SO4 2 minus is called as sulfate coming from sulfuric acid, and HSO4 minus 1 is called as bisulfate, or it is called as hydrogen sulfate. If you have understood the logic, we go to a brother of sulfuric acid, sulfurous acid. Sulfurous acid has lesser oxygen, and if you know oxidation number method, its charge is +3, or oxidation state of sulfur is +3, and oxidation state of sulfur is +6. Those who understand oxidation state, for them this data was there. So that data, if you want, I'll write on sulfur here is +6, sulfur here is +4. An ion coming from us acid will be getting the name as ite. Will get the name as ite. Are you understanding it? Now, sulfurous acid, if added to water, gives you 1H plus. So what do you expect is a charge on the remaining ion? -1. Total charge should be 0, as you are able to see here. Such an ion with hydrogen, acidic hydrogen present in it, gets the name as what? Bi. So bisulfite. If bisulfite is added to water, it gives you H plus and gives you SO3 with a charge of -2, which gets the name as sulfide. So what's the learning in this case? The learning in this case is SO3 2 minus. Why 2 minus? Because there are 2 H plus. Get the names as sulfide, while HSO3 with a charge of -1 gets the name as bisulfite. So this is how technically you can remember the anions, and this method of remembering anions will go a long way to remember various anions. You can pause this video and try to write down what you have just learned and practice it. Hope you have done it. If you have done it, we go to more acids. Oh, more acids. First, nitric acid. If you take nitric acid, it gets the name as ake because it has more oxygen. It gets the name as as because it has less oxygen. And those who know redox reaction method, nitrogen oxidation state is +5 in nitric acid. In this case, it is +3. Lower oxidation state as, higher oxidation state ake. If you take nitric acid, add to water, naturally it will give you H plus. What is the remaining? Yeah, NO3. But what charge? Correct, -1. Because total charge should be 0 on the right hand side. So +1 and -1, total charge will be 0. What is the name of the anion? NO3 -1. It is coming from which acid? Anic acid. So what do you expect? Yes, correct, nitrate. Nitrous acid gives you H plus. And what is the charge on the remaining part? Now by this time we have started understanding it, and we can clearly and quickly see it's -1. Now this anion NO2 with -1 comes from which acid? Yes, it comes from us acid. If it comes from us acid, what is its suffix? Yeah, correct, ite. So it is nitrite. What you learned just now? NO2 -1 is called as nitrite. NO3 -1 is called as nitrate. Correct. Pause the video, write it down in the notebook, practice it, understand it. Hope you have done it. Coming to the next set of acid. Next set of acid. More oxygen, phosphoric, less oxygen, phosphorus. Those who know redox reaction concept, then phosphorus is +5, higher, so 8. In this acid, phosphorus is +3, so us. And for your understanding, only P is written by the name as phosphorus. The correct spelling of the phosphorus in the world is this. Remember, this is OUS is a specialized spelling of phosphorus. Now, when phosphoric acid gives you 3H plus, what do you expect will be the charge on the remaining part? Yes, 3 minus. And the ion comes from ic acid. Because it comes from ic acid, it gets the name as phosphate. So PO4 3 minus gets the name as phosphate. While us acids से जो ion आएगा by removal of 3H plus will be what? It will be 3 minus and will get the name as what? Yes, phosphide, because it's coming from phosphorus acid. So remember, PO4 is phosphate, PO3 is phosphide. You know what to do now? Correct. Pause the video and write and practice. Similarly, you have learned, right, perchloric acid, chloric acid, chlorous acid, hypochlorous acid. I suppose you have not forgotten till. Correct. So by removal of H plus, the ion will be with -1. After removal of H plus, the ion will be still -1. After removal of H plus, still the ion will be -1. After removal of H plus, still the ion will be -1. So all these anions that you are able to see, they have the same charge of -1 because they were all having only one hydrogen. If it is coming from chloric acid, yes, chlorate. If it is coming from chlorous acid, correct, chloride. If it is coming from perchloric acid, perchlorate. If it is coming from hypochlorous acid, correct, hypochlorite. But are you able to see? There is a logic everywhere in the writing the name, and there is a logic for remembering the charge. So henceforth, whenever you find ClO4 minus, remember perchlorate. Wherever you find ClO3 minus, correct, chlorate. ClO2 minus, chloride. And ClO minus, hypochlorite. Correct, hypochlorite. That was how you can remember. Correct. If you have understood, we go ahead with learning. Oh, carbonic acid. You know carbonic acid? You get it when carbon dioxide dissolves in water. Carbonic acid. Carbonic acid, when it loses one H plus, it will have one negative charge. And this one negative charge, anion, when it loses one more H plus, it has -2 charge. So it is coming from ic acid. So it will be called as carbonate. It is coming from ic acid, is called as carbonate. Oh, both cannot have the same name. Yes, as a student you are correct. It should be called as bicarbonate. So remember, HCO3 minus gets the name as bicarbonate, and CO3 2 minus get the name as what? Carbonate. Yes, you should also know it is also called as hydrogen carbonate. Carbonate, correct. Hydrogen peroxide is also known as weak acid. Those who are not aware, new information for you to remember. Hydrogen peroxide, when it gives you H plus ions, 2 H plus ions, can you tell me what will be the case? Yeah, there will be 2 oxygen and will have 2 minus. If there is an anion coming from hydrogen peroxide, it gets the name as peroxide ion. So O2 2 minus gets the name as peroxide anion. So peroxide anion. So unusual for us to remember peroxide. So there are certain anions involving metal atoms too. Zinc with 2 oxygen. You want to remember the charge on it? How to remember charge on it? Zinc has a charge of +2 in a normal case. 2 oxygen, each oxygen has a charge of -2. So what is the charge on the anion? This charge we are trying to calculate. So what is the charge? If you solve -2. So -2 is a charge. Similarly, what is the charge in the next case? Lead is +2 in this case. 2 oxygen, each oxygen -2. So what is the charge? -2. So 2 minus is the charge in the next case. What is the charge in the next case? Aluminium with 2 oxygen. Aluminium has a charge of +3. Oxygen has a charge of -2. If you solve -1, so it is -1, or you can write on 1 minus. Similarly, if you are trying to find out this anion involving a chromium metal, then chromium has a charge of +6. Oxygen has a charge of -2. So what do you expect is a charge? Yes, 2 minus. Now, this ion gets the name as zinc and has the word 8, zincate. While this gets the name as plum because it's coming from lead, and gets the name as ite, plumbite. Why? Because there is a lead with +4 also. That would have been called as 8, plumbate. But this is with lesser oxidation state or valency, therefore ite, plumbite. While aluminium +3 is the only oxidation state, so you'll say aluminate. Only one, and only one, so that will be the higher one. Zinc has also only one oxidation state of +2 or a valency of +2, only one. You can consider it as the highest. So zincate, aluminate, chromium, this is the higher oxidation state. So it gets the name as what? Chromate. It gets the name as chromate. So zinc, ZnO2 will have what charge? Yes, -2. Pb will have what charge? PbO2 with -2. AlO2 will have what charge? -1. CrO4 will have what charge? -2. So pause this video, write down this anion, write down their correct charge, and write down their names. So you should have done it. If you have done it, the next one. Chromium with +6. So 2 chromium are present here with +6, 7 oxygen. So charge is -2 or 2 minus. This also will get the name as chromate. But now you can't write both the names as chromate. So what science does? Yeah, it notes that there are 2 chromium. So calls it as what? Dichromate. So we remember CrO4 as chromate, CrO2 minus Cr2O7 2 minus as dichromate. Correct. Then there are other anions too. What are the other anions? You remember this is called as hydroxide. For us an exceptional case, unusual, because we know IDE is used by elemental anion and used by non-oxy. This has oxygen. Silicon, common oxidation state, +4. So what is the charge here? +4 +3 into -2. So charge will be what? Correct. 2 minus, and the name is silicate. Name is silicate. So SiO3 2 minus is silicate. Anions. There are confusing anions. This, yeah, elemental anion, oxide. Yeah, this came from hydrogen peroxide if you remember. So peroxide. Peroxide. Oh, this is unusual because this is also 2 oxygen. This is also 2 oxygen, but it has -2 charge. This is minus 1 charge. So it gets the name as superoxide. Superoxide. Now those who want to know why such unusual names and what is the reason for it. For you to know this is an elemental anion. And you know elemental anion ends with what? ID. Yes. And why 2 minus charge? Because you remember oxygen was 2, 6. So it will require 2 electrons to complete its octet. Why this got the right second one got the name as peroxide? Because it came from hydrogen peroxide. Or you should know oxidation state of oxygen in this case is what? Minus 1. Can I say minus 1 is greater than minus 2? Yeah. Minus 1 is greater than minus 2. You want to say something greater? Use the word hyper. So it should be called as hyperoxide. Hyperoxide. For convenience, they dropped the word hyper. And therefore, this anion got the name as peroxide. Why it got the name as peroxide? Yes, you are correct. It has higher oxidation state than oxide. Oxide is minus 2. This is minus 1. Now, if you can think, this is seen in this compound called as potassium superoxide. What is the oxidation state of oxygen? If you calculate, 2 oxygen has a charge of minus 1. 2 oxygen, charge of minus 1. Therefore, 1 oxygen has charge of what? Oh, minus half. Is minus half greater than even minus 1? Yes, it is still greater. How to say still greater? Alright, still greater, you add super to it. So superoxide. Superoxide, you want to say oxygen is still higher oxidation state. So as a student, this confusing anion, you have to write and remember. So O2 minus is called as oxide. 2 oxygen with 2 minus is called as peroxide. 2 oxygen with 1 minus is called as superoxide. So go ahead, pause this video, try and practicing this in your notebook and try to remember it. It's important. Now this is something unusual for you to know. OH can be present as an anion like in sodium hydroxide. Similarly, OH can be present in methyl alcohol too. Oh, what is the difference? In this case, OH is ionic. In this case, OH is covalent. Oh, similarly, Cl can become NaCl and be ionic, or it can be CH3Cl and can be covalent. Are you able to see? Ionic are written with charge, covalent are written with bond. Yes, correct. And they have a different name. The name in this case is called as hydroxide. It is called as hydroxide, while this gets the name as hydroxy. Are you able to see? As the nature of the group changes, their name also changes. If it is covalent, it is hydroxy. If it is ionic, it gets the name as hydroxide. Similarly, this gets the name as chloride, while this gets the name as chloro. If you know what is the IUPAC name of this compound? Yes, chloromethane. Now you understood when you wrote IUPAC name, we never use the word chloride. Instead, we use the name as chloro. In common system, it gets the name as methyl chloride. But common system is a common, right? It has errors. IUPAC right names and modern names, and they try to reduce error, and therefore they got the name as chloromethane. Now, are OH and Cl are the only such groups? No, there are more groups too. So surprising. Yes, if NH2 is ionic, like in this case, Na plus NH2 minus. Can NH2 be covalent? Yes, in this case. Do you know what is the name of this first one? It gets the name as soda amide. Soda amide. What's the name? Methylamine. Methylamine. That means when it is a covalent, it gets the name as amine. And when the same ion is ionic, it gets the name as amide. Oh, unusual for us to know. So when NH2 minus ionic, it gets the name as amide. When NH2 is covalent, it gets the name as amine. Even CN. Have you seen this? Potassium cyanide. Potassium cyanide is one of the most dangerous substance around. If potassium cyanide comes in contact with our blood, it causes death within 3 seconds. That's quick, far quicker. Potassium cyanide. Potassium cyanide, when CN is ionic, gets the name as what? Cyanide. Correct. And when it is CH3CN, what is its name? It is called as, if you want to know the name, IUPAC name, methyl nitrile. It gets the name as nitrile. There's one more name, it gets the name as cyano also. Remember, cyano or nitrile. So when CN is ionic, it gets the name as cyanide. And when CN is covalent, it gets the name as cyano or nitrile. Similarly, NO2. NO2 as ionic, KNO2 minus. You know what is the name of this? Correct. It is potassium nitrite, ITE. You remember nitrous acid? Nitrous acid? You remember? And you remember the anion coming from nitrous acid? Yeah, nitrite, potassium nitrite. And therefore, this name will be ITE, nitrite, when it is anion. While anyone knows what is the name of this compound? CH3NO2? Correct, nitromethane. And the grouping gets the name as what? Nitro. So, are you able to see? Right, there are groups which are anion as well as covalent. So, are you able to see? This is OH minus, anion, hydroxide, hydroxyl, hydroxy or hydroxyl. Similarly, Cl when it is anion, chloride when it is covalent, chloro. When NH2 is ionic, amide. When it is covalent, amine. When CN is ionic, cyanide. When it is covalent, nitrile or cyano. Similarly, when NO2 is anion or ionic, nitrite. And when it is covalent, it is nitro. So, small exercise will do. So, on your display, you are able to see anions. Go ahead and write down their names. So, pause this video and start working on the names and write down these names in your notebook. Hope you have done it. This gets the name as sulfide because it comes from sulfurous acid. It comes from sulfurous acid, therefore ending ite. This gets the name as bicarbonate because it comes from carbonic acid and it still contains, we call it as acidic hydrogen. So anion still contains acidic hydrogen, therefore the name bicarbonate. What is the name for this ion? Yeah, nitrite. Because it comes from nitrous acid. If it is coming from us acid, ending is ite. Then this fourth one gets the name as phosphate. Because it comes from phosphoric acid. What about the next one? It gets the name as cyanide. Because it comes from HCN, which is called as hydrocyanic acid. The next one gets the name as nitrite. But why? because it comes from elemental anion. But why charge of -3? Because nitrogen has electronic configuration 2, 5, so it has to accept 3 electrons to complete its oxidation state or to complete its octet, therefore 3 minus, therefore the name nitrite. If you have understood, there is one more exercise for us. What is that exercise that we have? That exercise that we have is identify the charge on anion. So again, you know what to do. Pause this video and write down what is the charge on each anion. Go ahead. So now check. It comes from sulfuric acid by removal of 2H plus, therefore 2 minus. While this comes from H3PO3, phosphorus acid by removal of 3 hydrogens, so 3 minus. Peroxide comes from hydrogen peroxide by removal of 2 hydrogen, so 2 minus. Perchlorate comes from perchloric acid by removal of hydrogen, therefore -1. And hypochlorite comes from hypochlorous acid by removal of 1 hydrogen, therefore -1. Hope you have got your answers correct. Now, if you have got it correct, there is one more small exercise for you. You can try out for this 3-1, and if you have gone wrong, please try to get it correct. Pause this video and write down the charge on this anion. Hope you would have done it. This gets the name as azide because it comes from hydroxide acid. Nitrite. It is an elemental anion. Elemental anion. So it will have -3. Carbide. It is also an elemental anion. And you know carbene has electronic configuration 2, 4 as an anion. It has to accept 4 electrons to complete its octet, therefore 4 minus. So you got a difference. Azide is N3 minus 1. Nitrite is N3 minus. Now one more exercise. That exercise is write the formula with the charge of the following anion. So try doing it for this 5. So pause this video and go ahead and write down the formula with the correct charge. Hope you would have done it. Silicide, elemental anion. Ide means elemental. So 4 minus. 4 minus. Phosphide. Oh, it's also an elemental. So P3 minus. Because you know phosphorus is 2, 8, 5. It requires 3 electrons more to complete. Silicon is 2, 8, 4. Requires 4 electrons. Oh, it comes from phosphorus acid. Therefore, PO3, 3 minus. Phosphate, it comes from phosphoric acid. So PO4, 3 minus. Nitrite, oh, it should come from acid, nitrous acid. So NO2 minus 1 by removal of this hydrogen. By removal of this 3 hydrogen. By removal of this 3 hydrogen, charge will be complementary. Now, if you have done any error, you get a next opportunity to try the next 5. So go ahead and make it a point that you get it correct. So use all this opportunity to work on and get the things correct. Pause this video, go ahead. Yes, hope you would have done it. Bicarbonate comes from carbonic acid. By loss of 1H plus, what remains is -1. Zincate, ZnO2 and 2 minus, because zinc has +2 charge. 2 oxygen minus 2, so therefore charge is minus 2. Illuminate. AlO2 is the anion. Aluminium plus 3, oxygen minus 2 with 2 oxygen, so charge will be minus 1. Dichromate, Cr2O7 2 minus. Plumbide, PbO2. In plumbide, lead is in the lower oxidation state of plus 2. 2 oxygen with minus 2, so charge is minus 2. Plumbide is PbO2 2 minus. You can verify all the answers. Now, one more for you. Last one. Pause and go ahead and write down.